Hello friends, now this is the second lecture of our chapter first. Now in the last lecture we are studied about the different concept. The first concept we are studied that what is meant by motion. Second concept, what is the difference between distance and displacement. Third is what is the difference between the speed and velocity. What is the difference between scalar and vector. Then we are studied about the concept of acceleration and what is meant by positive uniform motion, negative uniform motion, and then we are studied about the concept of acceleration. Right now, today we are going to see the distance time graph for uniform motion. Now, this table shows us about a distance covered by car in a fixed time interval. Now let us try to plot this graph with the help of this table. Now for that purpose, let us point out the points. Now see here, for 0 the distance is 0, right? For 10 it is 15. For 10 it is 15. For 30 it is 45. For 30 it is 45. Right? Now for 60 it is 90. For 60 it is near about 90. 80 to 100, yeah? In between 80 to 100, 90. And now if we draw a line from all these points, we find that the line is a straight line. An object in uniform motion covers equal distances in equal time interval, thus the graph between distance and time is a straight line. Right? Now let us consider distance time graph for non-uniform motion. Now here when we observe this table, we find that the time slot is 0 to 5, 5 to 10, 10 to 15, up to the 35 minutes. But the distance which is given in meter, 0 to 7, 7 to 12, 12 to 20, 30, 41, 50, 58. That is, the distance is unequal. So this is non-uniform motion. Now when we are going to plot the graph of this one, we find that for 0 it is 0. We find that the line is not a straight line. So this is a graph of non-uniform motion. Now how can we now see for 5 minutes? Now suppose that, let us try to draw that graph. Now see here. We find that the graph is not a straight line because the distance is different. In between 5 to 10 minutes seconds it is only 5 meter. From 10 to 15 seconds it is 8 meter. From 20 to 25 seconds it is near about 11 meter. It means that when we plot the graph, we find that the graph is not linear, that is not a straight line. So this graph is called as the distance time graph for non-uniform motion. Right? Now let us see about the equation of motion using graphical method. This is very important topic. Now this, in the last syllabus, this equation of motion is in algebraic form. Now it is given by graphical method. Now Newton studied motion of an object and he prepared three equation of motion. The first one is v is equal to u plus at. Second one is s is equal to ut plus 1 half at square, and third one is v square is equal to u square plus twice a. V is equal to u plus at. This is the relation between velocity and time. S is equal to ut plus 1 half at square is the relation between displacement and time, and v square is equal to u square plus 2as each. This is the relation between displacement and velocity. Here u stands for initial velocity, v stands for final velocity, t stands for time, a stands for acceleration, and s stands for displacement. Now this equation can be describing the relation between velocity and time. For that purpose the figure is given. Now when we try to derive this equation by graphical method, we have to draw first of all this velocity time graph. Now in this velocity time graph, we find that figure shows the change in velocity with time of a uniformly accelerated object. The object starts from the point D. Now see, this is the point D, right? Now in the graph with velocity u, its velocity keeps increasing and after time it reaches the point B. Now it is the point B on the graph. The initial velocity of the object is equal to u is equal to OD. Now see here, this u is equal to OD. The final velocity of the object is v is equal to OC. Time t is equal to OE, right? Now the formula of acceleration is change in velocity, that is final velocity minus initial velocity upon time. Now we already noted that final velocity is equal to OC, initial velocity is equal to OD, therefore OC minus OD, and for time it is t. Now here acceleration OC minus OD is nothing but the distance CD, segment CD, right? Now see once again, OC, this is the segment, minus segment OD, which gives us equal to segment CD. Therefore CD is equal to, here OC minus OD, here we can write CD, right, upon t, and A is equal to, now the formula become A is equal to CD upon t, therefore CD is equal to AT. Draw a line parallel to y-axis passing through the point B. Draw a line parallel to y-axis, this is y-axis, right, parallel to y-axis passing through point B, and this will cross x-axis in E. Draw a line parallel to x-axis passing through point D. This will cross the line BE at point A. From the graph we can say that B is equal to AB plus E. BE, now see, this is BE, is equal to AE, AB plus AE, right? Therefore V is equal to CD plus OD. Why it is CD plus OD? Because AB is equal to CD. Now see, AB is equal to CD and AE is equal to OD. Therefore we write V is equal to CD plus OD. V is equal to AT plus U. We already proved that CD is equal to AT. We prove that CD is equal to AT. Therefore here we are writing CD is equal to AT and OD is equal to U. OD is equal to U. OD is equal to U. Therefore we get the equation V is equal to U plus AT. This is the first equation of motion. Now let us try to consider the second equation of motion, derive the second equation of motion. Now for that, let us suppose that the object is in uniform motion A and it has covered the distance s within time t. From the graph in figure 1.9, the distance covered by the object during time t is given by the area of quadrilateral quadrangle DOEB. DOEB. Now see once again DOEB. Right? Now area of this quadrangle is equal to area of rectangle DOE plus area of triangle DAB. Now see area of triangle DAB. This is the triangle, right? And rectangle DOEA, right? Now here we know that what is the formula of area of rectangle? It is given by length into breadth. Therefore S is equal to AE into OE plus area of rectangle, which is given by the formula 1/2 into base into height, that is 1/2 AB into DA. But AE is equal to U, OE is equal to T, and because DA is equal to T, OE is equal to T, OE is equal to DA is equal to T, AB is equal to AT. From equation number 1, we get S is equal to UT plus 1/2 AT square. This is Newton's second equation of motion. S is equal to UT plus 1/2 AT square. Now see once again here AE. Now see here AE. AE is nothing but OD, which is equal to U. Therefore, instead of AE, we are written U. OE. OE. Now see here OE, that is traveling from initial point to final point, the time is given by the t. Therefore, for OE we written t, right? And AB is equal to AT. AB is equal to CD, and CD is equal to AT, that we are already proved in equation 1, right? Therefore, we write AB is equal to AT. And DA, once again DA, which is similar to the OE. When OE is equal to T, DA is also T. Therefore, we write instead of DA T. Therefore, we get the equation S is equal to U into T plus 1/2 AT into T, which becomes S is equal to UT plus 1/2 AT square. This is Newton's second equation of motion. Now let us study equation which describe the relation between displacement and velocity. That is third equation of motion suggested by Newton. Now for that purpose, we are again going to use the figure 1.9. Now here we have seen that from the graph in figure 1.9, we can determine the distance covered by the object in time t from the area of quadrangle DOEB. DOEB is a trapezium. Now note that DOEB is a trapezium. So we can use the formula for its area. S is equal to area of trapezium DOEB. Now the area of trapezium is given by the formula 1/2 into sum of lengths of parallel side into distance between the parallel side. Now from this trapezium DOEB, now see here DOEB, these are the parallel side DO and AB, and OE is the distance between these two parallel lines. Now see S is equal to 1/2 sum of lengths of parallel side OD plus B into OE, but OD is equal to U, B is equal to V, and OE is equal to T, that we explained already. Therefore, we get S is equal to 1/2 into U plus V into T, right? But here A is equal to V minus U upon T. Therefore, T is equal to V minus U upon A, right? Now, by substituting this value of T here, we get S is equal to 1/2 into U plus V into V minus U upon T. S is equal to V plus U, V minus U upon 2A, but V plus U in first bracket and V minus U in second bracket gives V square minus U square. Therefore, instead of writing V plus U, V minus U, we write V square minus U square. This 2 is good goes toward left hand side, so we get 2as. Therefore we get the equation v square is equal to u square plus twice a. This is Newton's third equation of motion. Now let us see what is meant by uniform circular motion. Now this word actually tells us about the definition of uniform circular motion. When a body moves in a circular path with uniform speed, its motion is called as uniform circular motion. In this case, we find that the body is moving in a circular path with a uniform speed. Therefore, this motion is called as uniform circular motion. Now, if we consider the example of that uniform circular motion, the motion of a stone in a sling or that of any point on a bicycle wheel when they are in uniform motion. These are the two examples of UCM, that is uniform circular motion. If an object moving along a circular path of radius r takes time t to come back to its starting position, its speed can be determined by using the formula. Speed is equal to circumference upon time. V is equal to circumference is given by the formula 2 pi r. Time is given by the letter t. Therefore, the uniform circular motion is given by the formula V is equal to 2 pi r upon t. Right? Now, in the next lecture, we are going to solve some examples based upon these formulae that we are learned. Right? Thank you.